Okay, I'm sharing my screen. Just say yes in chat box. Is it visible? Yeah. Okay, Ravindra, thank you so much. Okay, so we're talking about the utilities. When we say utilities, it will come under water, brain, hot oil, steam, uh, brain, chilled brain, etc. To use in our process for various applications, heating and cooling applications. Majorly, these are the two major applications of utility, either for cooling or either for heating applications. So as you know, the hazards of such utilities are not only because of their sudden release. When I say sudden release, for example, leakage of the steam or leakage of hot oil or explosion of any pipeline, but also due to their working parameters. So it is a working parameters. All the utilities are under pressure and also under the temperatures, either a normal temperature to very extreme temperatures and extreme low temperatures, extreme high temperatures and extreme low temperatures as well, and also their flow. So it will, hence the pressure is there, automatically the flow also will be there. Then leakage and dripping, oil dripping, it is resulting in a contamination, sometimes toxicity, flammability, hot oil, and hazards of the vessels, even the pipings, the hot oil storage vessels or the storage tanks, the piping and also equipments, instruments through which they pass. Even their equipment failure, instruments failure, piping failures, even vessel failure, or uh, the vessels are involved in accidents, then also a hazard with the utility. Uncontrolled processes or water may corrode the things, and the air pressure can burst the vessel, or through dust, thermic fluid leakage can cause fire or explosion. Inert gas diminishes oxygen level for breathing, and also electric power and steam has already caused many accidents. So uncontrolled process or firewater may corrode the things. Uncontrolled processes can corrode the things, in the sense the vessels or the pipelines or fittings. And air pressure can burst the vessels. The pressure of the vessels can burst or throw dust. Sometimes the pressure, it can also throw dust, fumes, etc. Thermic fluids leakage can cause fire. When you say thermic fluids, hot fluids can cause a fire or explosion. And inert gas diminishes oxygen level for breathing. So diminishes in the sense it replaces. So whenever nitrogen comes in, it is heavy uh, at the vapor density, so that it will automatically take out the oxygen from the immediate vicinity, which means where the nitrogen enters, where the oxygen can leave that space. Like nitrogen is a dominator. And also electric power and steam has already caused many accidents. As we know, electric power, short circuit, and also steam leakages, even the steam pipes, the pipes which are flowing these utilities, also a severe hazard if it is not properly insulated. So when you say insulation, if it's a hot oil line, if you are not insulated the hot oil line, what will happen? It will also in the same temperature. So somebody accidentally get in contact with the pipe, then it will result in burn injuries. In same way with the steam, and same way with the chilled brain or brain, where it is in a very low temperatures, there you will get a cold burns. Both will be impact with the humans, either cold burns or hot burns. Cold burns become white fingers, hot burns, it will burn our tissues. Either we have first degree burns, second degree burns, or third degree burns. The cold burns will frozen our body parts, it will become brittle nature. It will kill the nerve cells, froze the nerve cells uh, to block the blood circulation. Okay. A refrigerant gas freon causes ozone depletion and thousands of tons of hydrocarbons and also carbon dioxide emitted by fuel combustion pollute environment. This is what now the entire world is fighting against. Carbon dioxide emitted, GHG, greenhouse gases. Anybody familiar with GHG? This is also very interesting topic. Nowadays, most of the safety professionals, they are learning sustainability or ESG skills to shift their career from safety to sustainability. So you are new to this. Whenever you get a chance, you try to learn the skills with respect to ESG or sustainability. So it will help you in your career. So it is going to be an additional weapon in your resume, or it will give an additional weightage to your resume when you attend for any interviews. Because nowadays the sustainability and the ESG skills are highly demanding in the market.
So suggest us some good organizations or any institutions which provides ESG certification so that we can.
I mean, if you see, Mohammed, there are so many certifications. Like majorly in the market nowadays, looking for GRI certification, and then ISO 14067, 14064. It is for GHG accounting. There we have series of trainings 1, 2, 3, but it will become costly actually. So certification is matter whenever it is in a more competition. If you are skilled enough, even if certification is not there, also the people will accept your profile.
Noted, sir.
Certification is a gate pass actually. If you ask me, sometimes even if the gate pass is not there, also we can get through. But we have to learn the skills with the practical scenarios or with the real-time examples, so that you can clear the interviews. I can help if anybody interested. I can help, no problem. Okay. Okay, let us come back. So nowadays, as I said, the carbon dioxide emissions due to the combustion of this fuel sources or fossil fuel sources, amount of carbon dioxide, it is also one of the major GHG, greenhouse gas, which is impacting the climate, resulting. You could nowadays we can see the temperatures. If you see the rainfall has started very early this year. Majorly, if I'm not wrong, by end of the May, this rains will start. But this year, even from the mid of the May itself, we could see the rains are starting. And since the seasons are shifting because of this climate change. Okay. Then noise and vibration due to high flow of steam or air and other health hazards due to misuse of air, water, steam, electricity, and nitrogen are not uncommon. Okay, noise and vibration and other issues. Then in distillation column, so condenser when cooling the water stops due to the heat rises, pressure increases, and also bursts the condenser or sometimes causes a back pressure in the distillation vessel itself and burst it. So whenever the column condenser, when the cooling water stops, so in the condenser column, whenever you do a distillation, any chemical, so it will reaches to a certain temperature. I mean, it reaches to the boiling temperature. Then you will get the required element or the required chemical. It will convert into steam. Then you are condensating it. It means you are converting from gas to liquids. So where the water is not coming. Most of the we use a cooling source as water. So if the water is not passing through this condenser, what will happen? Even this condenser also heating up. Also, it will increase the pressure because of condensation is not happening. Then it will result in a bursting of the vessel itself. The pressure relief devices on the such vessels, condensers, and even on receivers are therefore necessary. So In case of such instance happen, maybe we are not given the focus on uh, enough focus on the condenser or the pressurization or the water intake of the condenser, then we should get the result of an accident or result as an accident. So there we have to keep the pressure relief valves in case of any such over pressurization. It can able to relieve. High pressure temperature alarms interlocked with heat source to cut off the heat supply at the predetermined pressure or temperature can work as safety devices for quick cooling. Water supply standby pump motor sets DC set or overhead water tank to get water by static head only or any or also necessary. So for the high pressure temperature alarms we require. So whenever it reaches to the high temperatures, so it can able to given a hint above the temperature has been increased than required or than expected, so that the people will immediately get alert. How like will be alert while going on road once if you see in a siren, either police or either ambulance, you'll get into a quick attention. Okay, something is happening or something is coming. The same way, you should have an high temperature alarms so that it can able to alert the team so that they can take an initiation. And predetermined pressure and temperature can work as a safety devices. So we'll set the predetermined set pressures and set temperatures so that they'll work as a safety devices. A quick water supply and the DC backup also required for the in case of any power failure. And there is no common water reservoir for the process or fire water both. The suction pipe for the fire water pump should be deeper than the process water pump to allow a reserved stock of fire water for emergency. So it is just a basic uh, technique, like how like in our two-wheelers, you will have general and reserve. When I say reserve, here it is a fire water suction. So reserve always, the reserve pipe is always deeper than the regular suction. Reserve means there is a some more fuel will be vacant to go for the last minute. So here the thing is, if you didn't have a separate water storage for the process and the fire water, so we have to keep the fire water more deeper than the process water, because it is very fire water is very important. Even if the process water is not there, we can stop the process. In case of any emergency happen, if the water is not there, it will be difficulty to handle. Then pollution hazards and controls. So as we know, the chemical industries discharges solid, liquid, and gases waste as a result of their manufacturing process. Even sometimes not only the manufacturing process, there are great people. They can release their residues by the reverse boring. We have noticed some of the cases in the various industrial parks. I don't want to take the names or the locations. It happens in everywhere. So once you caught up, so you'll be the victim. Okay, that is also one thing happen. And also even especially in the nights, they switch off their scrubbers so that they can save some energy, as well as neutralizing agents there where you can feel the chemical smell, especially in the nights. Sometimes they will release the vents. So these are the great things people will do. So we should be very careful with them. So that's where the pollution control have installed the continuous air monitoring system, CEMS, or continuous emission monitoring systems, not air, continuous emission monitoring systems. There they can monitor your performance of your the vent, how you are uh, cleaning them, how you are purifying your waste or the gases. Such waste may be toxic, flammable, corrosive, radioactive, non-biodegradable, or hazardous in nature. And if it is not properly treated, it pollutes land, water, air, and overall environment. So there may be a toxic, sometimes may be flammable, sometimes may be corrosive, or radioactive or non-biodegradable, it will not degrade automatically. For example, plastic, it is not degrade. It takes time and also hazardous in nature. If it is not properly treated, it can pollute everything. Even if you see some of the industrial areas, we used to say that okay, our groundwater got polluted, our air is polluted, especially the Delhi region. In the crop, after the crop in summers, they used to, the farmers used to burn their paddy waste. Then it will pollute uh, the Delhi air quality or the air. Water, soil, land, and air pollution create many problems and need efficient control, efficient treatment plants, and appropriate scrubbers, exhaust, flare, incineration, and other neutralizing or inactivating devices are most desirable, and they must work for all working hours in an effective manner. So, air water pollution creates many problems. It needs an efficient control. Many problems in the sense, if it is in heavy metals in that, so you will get various diseases and effluent treatment plants and appropriate scrubbers, exhaust and flares. So effluent treatment plants, we can treat our whatever the effluent we are generating. Then scrubbers to treat your fumes or emissions, and exhaust systems to take out your from the immediate vicinity, and flare. So whatever which is going out of your stack, it can be incinerated so that there will not be any formation of uh, the vapor clouds, and other neutralizing or inactivating devices are most desirable. So other process controls also utmost required for avoid the pollution. They must work all working hours. So it is not mean that okay, whenever inspector of factories comes, yes, everything will work fast, everything will be smooth. Whenever US FD audit comes, everything will be clean, everything will be working. Whenever any customer audit comes, so everything will be working, everything is fine. Not like that. So it should be always 24/7. Whenever your processes are in active, whenever your process is in running, all these control devices are should be in active mode so that we can avoid the pollution. Then instrumentation for safe plant operations. So we use different kinds of instruments in our operations. So after understanding various types of chemical hazards, now in foregoing parts, we should proceed or know instruments, equipments, or other control measures to understand better. To maintain control, measure, alarm, and also record process parameters, various industrial instruments and also safety devices are used, and their appropriate selection, application, and maintenance are utmost important. Okay. So we have pressure instrument for temperature related or controls, relief devices, various instruments we use to see the process control, to define the process controls. Anemometers, so instrument for measuring speed of the wind, etc. Then barometers for measuring atmospheric pressures. Bolometers, an extremely sensitive instrument for measuring heat radiation. A calorimeter for determining quantities of heat evolved, absorbed, or transferred. Hydrometers for measuring density or relative density of the liquids. Monometers for measuring the gaseous pressure. I think these monometers we could see on the over the reactors, correct? And gas, fume, vapor detectors or alarm or leakage warning instruments, where we'll have the electronic instruments having sensors and also audible alarm to give warning when a preset air, gas, or toxic or explosive mixture exceeds the TLVs. So we'll set this leakage or sensors over the TLVs, threshold limit values, so that it can trigger the alarm. Then LEL UL limits, it detects the flue gases, LPG, smoke, petrol vapors, paraffins, fumes or hydrocarbons, ammonia, freon, hexane, acetone, benzene, chloroform, fumes or COHs, methane, solvents, etc., and other poisonous and explosive gases. And various types of gas detectors are Handle models are also available. So metal detectors, it detects the metallic objectives, ferrous, non-ferrous materials hidden in the pockets or bags. And electronic flashes, a built-in solid state electronic flashes within a can a flash maintains the bulb, or series lamps maintain the adjustable flashing rate. It can be used as a danger indicator. So electric flashers means where you will have as a lighting device. So it will be set for various levels. Based on that, it can change the colors and also intensity of the lighting. Then flame proof equipments, so switch gears, lighting fittings, even cable conductors, cable glands, and also accessories, etc. Switch sockets, limit switches, rotary cam operated switches, isolators, bells, tube light fixtures, etc. We use various junction boxes, etc. In this, we have type D, type E, which is increased safety, type N, which is non-sparking tools. All your non-sparking tools fall under type N, flame-proof equipments. Type P, which is pressurized, are to be selected for use in the hazardous areas. And it's a hazardous areas like we have discussed previously: zone 1, zone 2, zone 0, zone 1, and zone 2. Anybody can give quick answer for my satisfaction? Zone 0, zone 1, and zone 2.
Zone 0 is where the place where continuous gas is present, sir.
Yes,
And zone
example.
1 occasionally. Like a blowdown area, there may be chances.
Zone
जहाँ
0.
पे zone 1 like scrubber area, sir.
Okay.
जहाँ पे flanges ज्यादा रहता है.
Ha. Maybe
And zone 2 is the place where the presence is very occasional, like once in a while, or no gas
very,
at all.
very rare. The probability will be very rare.
Very
Okay.
rare, sir. Yes. Yeah.
When I say zone 0, there is a continuous
It's
presence.
continuous. Yes.
Yeah.
Right.
Yeah.
Yeah.
Where we can take an example of storage vessels or process vessels. Zone 0 will be where there is a chance of any leakage happens, then it happens. And zone 2 will be extreme cases, any accident, such kind of situation can happen. It means the probability or the chances of presence of the hazardous atmosphere will be very rare comparing with zone 1 and zone 0. Okay. Okay, thanks, Srinivas. Thank you so much. I'm happy. Okay. Then process control instruments for temperatures. We have so many. I mean, it is. To be frank, you will not get in your examinations write all these instrument names and all. Just for your understanding. Even to be frank, some of them I have not seen or I am not known also. So thermocouples, radioactive, optical pyrometers, resistant thermometers. We know only thermometer that it can give the temperature. And automatic electronic balance bridges or radiometers, etc. For pressure, we have strain gauges. I heard about this, and pressure transducers. This also I heard about. Pressure gauges. They are well familiar. Even vacuum gauges. These are also well familiar. Compound pressure and vacuum gauges, draft gauges, compound pressure and draft gauges, automatic pressure regulators. I think these are controllers. Gas pressure regulators, flue oil pressure regulators, direct acting regulators, diaphragms. Is also very familiar. Okay, high vacuum, bottom gauge, bellows gauge, diaphragm gauge, McDonald, Mickey load gauge. I'm getting McDonald's. I'm sorry. Okay. Uh, McLeod gauge, thermal conductivity. Even McDonald's also very hazardous to health. I'm just taking this advantage. I'm not against McDonald's. I'm against with the products they produce. Then for level liquid level indicators, the float gauges, mercury manometers, etc. For the flow liquid filled manometers, float type manometers, head flow meter, bell type meters or wet balance type meters, billios meters, etc. and quality analyzers or centralized control computers like DCS systems, digital control systems. Nowadays, most of the chemical process have this DCS control systems. Most of the uh, parameters they control remotely. Only few controls with the operator. Now, instruments for safety. So, instead of providing an elaborate or complex instrument system, the hazard should be reduced. So, sometimes there are hazards. So, you have put so many instruments instead of putting so many these things. It is try to reduce the potential of hazard or the nature of hazard, so that it will be helpful. And hazard study should be conducted to assess potential hazards, operating difficulties, and instrumentation necessary. Then the measurement should be a direct variable and also a direct location. While designing alarms and other factors like instrument failure, operator confidence, this information load, etc., should be considered. And as far as possible, instrument design should be a fail safe. Even though it is failed, it should be safe. Range of instrument should be sufficient so that even a low input can be measured. Range of instrument should be sufficient. So sometimes what will happen, your the pressure gauges. So it will be having from 10 to 50 kg. So beyond that, any low pressure, your instrument can't give any reading. So the range of instruments also should be properly selected. Then control system should be capable of dealing with all normal and abnormal conditions, startup and shutdown procedures. In case of any failure, auto controls, manual control should be also provided for the safety. So this is also very important. Sometimes while you're operating with the DCS system, the valves will not shut off. The valves we can't able to control because of maybe the pneumatic air is not properly working to control the specific valve. Then it should be having a provision to stop that excuse me flow manually. Then fault finding instrument should not be disturbed by a fault itself. So this is happens. The fault finding because of the instrument is fault, then also it will give an indication. Service instruments for air, power, and inert gas should have high integrity. So that is very important. Services. So if it is not properly working, it leads to worse cases. Instrument should be checked regularly and repaired quickly. So we have to check all the instruments on a regular basis to assess their performance. If it is not in working condition, it has to be attended immediately. Instrument design should be such that it should indicate its fault easily, and the process operator should be trained to find such faults as a part of his duty. So this is what we discussed in TPM, total productive maintenance. So whenever your operator is familiar with your instrumentation, whenever your operator is familiar with some of the process controls, some of the minimum basic maintenance, so that he can able to understand the healthiness of the machine. So if it is not functioning normally, so he can able to recognize. So you should know about uh, the pulse of the machine, then only he can able to operate properly. He can able to safeguard the machine, because maintenance team will have very short people, maximum 20, 30, 50. If it is in a very big company, 50 people is a huge number. So the operators will be very high in comparing with the maintenance department. That's where the maintenance team has to train all the mission operators in such a way that they can able to recognize, they can able to identify, they can able to sense in case of any malfunction of equipment, malfunction of a machine, a malfunction of an instrument, so that they can given a immediate feedback to the maintenance team, it can be corrected before leading to a major damage or a major breakdown. Okay, test should be correspond as nearly as possible to the unexpected plant conditions. It may pass a workshop test, but many not perform satisfactory on the plant. So some of the instruments, they may not perform at the they perform at the test center level, but once it comes to the real time scenarios, they won't perform as performed in the test centers. That is also a thing where we have to jam. The valves may be stick or jam. Jamming in the open position is dangerous. A more positive isolation may require a double block and bleed valves. So jamming in the open position. This is what I mentioned. So some of the valves it won't shut off by the DCS controls. So there we should have double block and bleed valves to correct such jamming. And human errors should be fully considered. Ergonomic principles should be applied to reduce human errors as far as possible. Okay, now some of the safety aspects with respect to the instruments. Instruments may fail due to the functional fault or loss of containment from the instrument, or the failure of the sensors or the integral part of the instrument. Slight glasses or rotometers are made of glass can break or leak. If leaks are dangerous, glass should be avoided. So some of the instruments will have with a glass. If there is a probability of damage of such glasses, where we can avoid the glass. A material of construction should be proper. So after considering the properties of the material to be handled and also working parameters, material for instrument should be selected. So MOC, material of construction. So how like for corrosions, corrosive chemicals we use glass lined reactors. For others we use SS reactors. Same way. So whichever the chemical which are passing through certain instruments, we should also check their MOC so that to see the compatibility. And pressure transmitters and regulators can be damaged by overpressure. If they break, their pressure should be safely released. So this is also important. In case of any failure, they can release safely, not in a hazardous manner. Protection against corrosive fluids is necessary. Example, use of inert liquids in a impulsive lines on pressure transmitters or of chemical diaphragm seal on the pressure gauge, so that we can able to protect them. Okay. Then sampling and impulse lines should be checked for blockage. Steam tracing is useful against the freezing. Some of the will have sample points for the collection of the sample. Sometimes they get choked because we will not take the samples every often. So sometimes they'll be choked. There we can use the steam to clear in case of any freezing. A thermowell to hold the thermometer should be carefully designed to take into account of corrosion or erosion. And a pulsating flow or flow meters can cause inaccuracies. Design of orifice plate should be considered this factor. So when I say orifice, basically it reduces the flow actually. I think, for example, uh, I'll just take a quick. For example, if you take this as a pipe, I think you people, some of them are familiar with. So this is the OD. I mean, this is the ID or OD, whatever it is. So this is the OD. So here we are putting an orifice. So we are putting one more thing. This act as an orifice. So it will reduce the flow. What will happen? Only from this small dia, only the chemical will come in. Even though the dia is 8-inch pipeline, you have insert an orifice for 2-inch, you will get only the chemical from the 2-inch this thing. That is called orifice. Then complex instruments like analyzers, speed controllers, vibration monitors, and also solids waiters are generally less reliable. The consequence of their failure should be carefully analyzed. Okay. For the time constraint, I'm stopping here. We have only 10 seconds. We can continue. This is the last slide actually. We have completed. I mean, we continue with